Hey boys and girls, this is week 7 remote work, properties and numerical expression. I'm going to go over the answers to this, so if you have any questions when you bring it back in, you can ask them. Alright, so the first page was a review of the properties that we're using in math. If we review the properties at the top, the new one for us was distributed property, and I just want to remind you that just says if you have a multiplication problem times a number, you can break that number into two parts and then multiply the factor by each part and you'll get the same answer. And that's shown by 8 times 2, rewritten here, plus 8 times 3, which is rewritten right there. So that's one example of the distributed property. Okay, at the bottom of the page, you had to find the sum or the product. So for number 1, the answer was 87. For number 2, the answer was 0. And for number 3, the answer was 31. Okay, on number 4, you had to complete the equation and tell which property you used. Well, I can see that this side of the equation has 2 times 5 plus 2. And I can see over here it's been distributed out. A 2 times 5 plus a 2 times 2. So I know that that is the distributed property. On this side, I can see that my equation has to be equal to 15, so I know that 15 times 1 is equal to 15, and that's using the identity property. On the back side of the sheet, you have more practice with the properties, and so I've highlighted what you need to key in on. The first one asks about the identity property of multiplication. The only one that means the identity didn't change, so the only one that's multiplying by 1 is B. Number 2, it's asking for an example of the associative property of addition. I know associative property has to do with grouping, and more parentheses are grouping symbols, and this is the only one that uses the grouping symbols and doesn't change my digits or change the order of the numbers in the expression. So my answer is going to be A. Number 3, the commutative property of multiplication. I know commutative property says order doesn't matter, and problem B shows that property. Number 4, it asks which property is used in this example. I can see that they are distributing the problem by multiplying 6 times 2 plus 6 times 9. So the answer is going to be C, distributive property. In number 5, it says which of the following does not show the commutative property of addition. Well, the first thing I'm looking for is something that doesn't have an addition in it. And this one right here means A multiplied by B equals B multiplied by A, which I know is commutative property, plus it's multiplying. So I know the one that is not addition would be C. Number 6, which property of addition is used in the following? I can see here that the digits are all the same, but they are regrouping. Here they're adding the 3 plus 5 on this side of the equation, and over here they decided to regroup it with the 5 plus 3. So I know that is the associative property. Number 7, which property could you use to simplify the following expression? I know that this is 2 times a number that's been distributed, so I know this is going to be the distributive property. Number 8, which property of multiplication is shown? Once again, we're getting lots of practice with distributive property. 2 plus 8 times 7 has been distributed as the 2 times the 7 plus the 8 times the 7. Number 9, which property is used in the following expression? All right, I'm looking to see it's all multiplication. All the digits are the same. They've just regrouped. In this one, they're multiplying the 3 times 7 first. Yet over here, they're multiplying the 2 times 3 first. So I know this is the associative property of multiplication. And then the last one, which property of addition does this example illustrate? Well, I know when you add 0 to any number, it doesn't change the value of it. And I know this is called the zero property. All right, let's look at the numerical expressions for lesson 4.1 reteach. Here we read the example up in the top, and then we get down here to the bottom, and you have two situations that you need to write as a numerical expression. And you're going to remember that a numerical expression is a number expression. So in this situation, we have Eli who bought 3 packages of pencils. Each package contains 6 pencils. All right, so I know that's going to be 3 times 6. It is a equal group problem. Jarvis had 8 baseball caps. He gave 2 caps to his younger brother. I know that's going to be represented by 8 minus 2 because he started with 8 and he gave 2 to his brother. Okay, here we're going to work on some situations that we have to write as numerical expressions. It says write the expression to match the words. First, you need to recall that we have 4 operations, and the words sum, difference, product, and quotient are often used to describe the answer to an addition problem. Difference is the answer to a subtraction problem. Product is the answer to a multiplication problem, and the quotient is the answer to a division problem. All right, so when we read the first one, the difference of 10 and 3, I know that they want me to write an expression, 10 minus 3, the difference between 10 and 3. The product of 5 and 9, well, I know product is an answer to a multiplication problem, so I'm going to say the product of 5 and 9 like this. The sum of 3 and 11. I know the sum is the answer to an addition problem, so I'm going to write an addition problem to find that sum. The quotient of 20 and 2. Okay, so I know the quotient is the answer to a division problem, so I want to write a numerical expression that shows 20 divided by 2. Okay, number 5, there's actually 2 steps here that we're thinking of. We need to find 1/2 of something. What do we need to find a half of? The sum of 9 and 3. So I need to find the sum of 9 and 3, which is 9 plus 3. And once I have that, I'm going to have to divide it by 2 so that I can have 2 halves. Number 6, 2 times the difference of 5 and 3. This again, this is a 2-step problem that we're thinking about here. I'm asked to find 2 times something. 2 times what? Well, the difference of 5 and 3. So first I would have to find the difference of 5 and 3 represented by 5 minus 3, and then multiply that 2 times. On number 7, we need to find the quotient of 15 and 3 minus 4. So here I want to find the quotient of 15 and 3, which is going to be 15 divided by 3. And then I'm going to have to subtract 4. Now in this case, you might want to put parentheses around this, but it's not necessary. And I did notice I wrote divided by 4, and I need to write minus 4. One more reason you should always write with a pencil in math. Okay, on number 8, we have 7 times 4, then add 5. So I'm going to follow those instructions exactly. I'm going to multiply 7 times 4, then I'm going to add 10. All right, and so that's a brief overview of all those answers for that assignment on the page. All right, the next one we're going to do is the page 4.2 reteach, which is interpret numerical expressions. All right, so this is just understanding the relationship between different expressions and making sure that we understand what we're reading. All right, and so in this lesson, we were comparing 2 different expressions. Over here, we have 4 times 22 minus 6. And over here, we have 22 minus 6. And we were asked to compare them. All right, well, I can see that this expression over here is larger than this one. How many times larger is it? Well, it is 4 times larger because they are both the same in this part. But this one says 4 times that much. All right, so you're going to use that same logic on the rest of these. Here we're comparing the expression 5 times 7 plus 3, and here we just have 7 plus 3. Well, I know this first expression is larger. It is 5 times larger than the expression on the right. So 5 times 7 plus 3 is 5 times as much as 7 plus 3. All right, on number 3, 9 plus 8 is compared with 3 times 9 plus 8. Well, I can see that this problem over here, this expression is going to be 3 times larger than just the 9 times 8. Why? Because it says 3 times that much. So 9 plus 8 is 3 times smaller than 3 times 9 plus 8. And then our last one, we're comparing 5 plus 4 and 10 times 5 plus 4. And again, they're both the same in this respect. However, this one is 10 times as much. So 5 plus 4 is 10 times smaller than 5 plus 4. All right, let's look at the back side. And we have a few problems that we need to complete here. All right, you started with a word problem. I'm going to read it out loud and then we'll answer it. James is making banners for his club's airplanes to pull. Each banner is 5 feet long and is attached by a 10-foot rope. All right, so I'm going to go ahead and picture that in my mind. Each banner is 5 feet long, and then it's got a rope that's attaching it that is 10 feet long. He models the total length of the banners and rope for 6 airplanes. So he's going to do this 6 times. Whatever this is, it's going to be times 6. So he models that with the numerical expression 6 times the 5 plus 10. So we're getting the 5 plus 10 from the banner plus the rope. And then he's going to make 6 of those times 6. He says the total length for 6 planes is 5 times as great as the total length needed for 1 plane. Correct his error. Well, we know the total length for 1 plane is going to be 5 plus 10. The 5-foot banner plus the 10-foot rope. Now he needs 6 of these, not 5. So I know that he's made a mistake in thinking about how many times he needs this. So 5 plus 10 times 6 is correct, not times 5. All right, well, number 5, once again, we are comparing 2 of these numerical expressions. I can see that this problem over here and this part of this problem are exactly the same, but this says 9 times that much. So I can see that 33 plus 67 is 9 times smaller than 9 times 33 plus 67. I must put parentheses around that. Number 6, 4 times 2,101 minus 987, and comparing that with just 2,101 minus 987. Well, obviously this side is going to be 4 times greater, or 4 times as much. And I'm going to do a shortcut because I'm tired of writing all this stuff. This side is 4 times as much as 2,101 minus 987. Okay, so this one is a little bit different because it is comparing 56 times 9 to 8 times 9. Well, I can see that they both have a common factor of 9. And the only place they're different is this 56 and this 8. Well, I know this one's going to be larger, but how much larger? I'm thinking to myself that 56 is 7 times 8, and then add my times 9, or put my times 9 on there. This would be 7 times 8, and then times 9. And I would be comparing that to 8 times 9. Well, I can see this one's going to be larger, and it's going to be 7 times as much. All right, I hope that helped you on going over these problems so you can see which ones you have a question about for Monday. See you, well, not Monday, Thursday. See you Thursday.